Hello, 7th graders, and welcome to the extension lesson to 15.5. So you should have already listened to the lesson of 15.5. We are moving on to the extension part here, which is that I can design simulations. I can use simulations to find the experimental probability. Keeping our warm up. So here is what a simulation is. A simulation is an experiment that is designed to produce the conditions of a situation or process. A simulation allows you to study situations that are impractical to create in real life. So this is where, how do I explain this? This is where like big study things come into play, or big researchers do these things, and it's just not situational for us to try and recreate their whole entire experiment. And so what we can do is we can use simulations, and we can pretend like we're doing this experiment and set it up the correct way, but we're not doing it to the grand magnitude that others would be doing it to. So like adding more people, maybe more steps, so on. So we're going to simulate, or we're going to emulate this situation as we go through. So let's go ahead and figure out what they're talking about here and figure out how we could create a simulation of this. Okay, so basically making the experiment of it in an easier format for us to do. So example 1, a couple plans on having 3 children. The gender of each child is equally likely. Design a simulation involving 20 trials that you can use to model the gender of the children. I'm pausing right there. So here is why we're doing a simulation and we're not trying this, because you imagine how many like research you'd have to do into this and being like, okay, there's this couple A and this couple B and this couple C, and they all have children within 10 years, and it would take a long time. So we're going to create a simulation involving 20 trials that you can use to model the genders of the children. B, use your simulation to find the experimental probability that all 3 children are boys. Okay, so we want to know then, once we do this whole experiment, how many of these situations end up resulting with a boy, or with all 3 of the children being boys. Okay, so we're going to take the time and we're going to do this. My first thought is, the way I can simulate this is because there's the 2 genders, okay, male and female. We're not getting into gender fluid issues or gender identity right now. So we're just thinking about male and female. And something that has 2 options is a coin. So we can flip a coin 20 times, 3 times each, because we need 3 children, and see what we come up with. Okay, so I'm actually going to start by numbering out my notes right now from 1 to 20. Oh, I guess that my pen isn't on. So we got 1, 2, 3. Let's see if I can extend the page. I don't know why it doesn't like me extending this page. All right, we're gonna have to do this. Boop. 8, 9, 10. Oh, again, it doesn't like to extend it. All right, let's keep doing this. Sorry guys, stick with me. I will come on back once I got this all labeled. Alrighty, so now I have all my numbers set up, and what I did then from there, and I'm going to show you here, is I went online and I decided to find a random coin generator. So I ended up by Googling, I got to random.org. Okay, you can pick what kind of coin you want. I just went with a US coin, so for familiarity, and we want to flip 3 coins because we want to see with 3 children what's going to happen. Okay, so let's go back and look at this though. If it lets me, maybe not. so I'm going to go with the fact, and we can pick either one, but I'm going to just say that heads are going to be girls and tails are going to be boys in this simulation, okay? So let's go back then to our random thing. Let's flip our coins. All right, so our first one, we've got tail, heads, tails. So when I go back, again, it doesn't like when I flip this. So then I'm going to go back to my notes here, and we had tails, heads, tails, okay? I'm going to do this for 20 trials, and I don't want you to just sit here and have to do all of this. But here's the way we would simulate this, okay? So I'm going to go ahead and figure this out here. Catch me back in here in a minute. I'll catch you up at about 10, and then we will continue on. All right, here I am halfway through, and it does take a bit to get through. You go ahead, pause this video so you can write in then the answers so far that I've gotten. In this case, since I've only gone through half of it, there's only been one trial right now that has concluded with all 3 children being boys, with all of them being tails. So I'm going to continue on. Again, feel free to pause this. I'm going to continue on and find the other 10 values that we need. Okay. Alrighty, we got through it. Got through all of my simulations here of 20 different trials. Then my big part was B. Then we needed to decide what is the probability, or what is my experimental probability of getting all boys. So I actually ran into 2 trials that gave me all boys or all tails, which were trial number 5 and trial number 18. So out of my 20 trials, 2 of them resulted in all boys, and so my probability then would be 1/10, okay? So 1 out of 10 couples would end up having all boy children, okay? The more you do simulations, the more accurate they're going to be. So the more you, if you were to test this and do the like 50 trials, okay, you're going to get a little bit more accurate data. Or 100, but I'm not going to sit here and do 100 this day, okay? Alrighty, so let's look at the next one. What kind of trial do we have to set up? There's a 60% chance of rain on Monday and a 20% chance of rain on Tuesday. Design and use a simulation involving 50% randomly generated numbers to find the experimental probability that it will rain on both days. Ooh, alrighty. So we need to come up with 2 numbers, and we want to know what is the probability that they're going to rain on both days, okay? Let me think about this one. We need to use a random number generator, but how are we going to simulate that? We need 50 numbers? Whew! Sit here and do this for a long time. Trying numbers to find the experiment that will rain on both days. All right. So they are independent events. It doesn't matter if on Monday it rains and on Tuesday if it rains. They're completely independent events. And so what we're going to do is I'm going to generate 50 random numbers. Again, I'm going to try and Google and find a random number generator. If there's a 60% chance on Monday, we're going to say that any number between 1 and 60 would result in rain on Monday. Okay? Any number then, if there's a 20% chance, we're going to say, because we're going to set our numbers up from 1 to 100. Because that's going to be helpful with my percentage here. So then for Tuesday, the chances of rain is going to be anywhere from 1 to 20. Okay? So give me a minute, I will find a random number generator. Alrighty, when I looked to find a random number generator, I actually found one right away. When I set up here, you just Google it and they create a number, okay? So I want the minimum to be 1, 100 to be my max. Okay, so 92. I'm going to sit here and come up with 50 numbers, and I will write them then out on your notes. Whew, guys, I got my 50 numbers now. Oh my goodness. I have to say, this lesson is so much more fun when we get to do these experiments and simulations together. I feel like some of that aspect of doing this together is just so lost right now. So here is my 50 numbers, all the ones down here. What I'm going to do is I'm going to go through then and find all my ones. So let's start with my Monday. We have a probability out of 50 because we did 50 trials. Oh, I wanted this a different color. And I'm going to go through and count all the ones that are that is a number between 1 and 60. So I'm going to go down the list here. So 1, 2, 3. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We'll include 60. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 34. All right, so I just double checked it, but if I still get it wrong, let me know. But there are 34 out of 50 that are a number between 1 and 60. Okay, so that's my probability of Monday being rainy. Then my experimental probability, okay, because there's a theoretical probability of 60% chance. We're talking about the experimental, so once we went in and did an experiment. So now I'm going to go through, let's count up all the amount that are 20 or less. So again, you had 50 different trials, so let's count all my numbers. This might be a little easier. So 1, 2, 3, well, include 20. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, when we find our probability, we want to multiply these together. So at the bottom, I'd have 2,500. And then let's see, what is that going to be? 34 times 13. 442. We could definitely divide this by 2, maybe 4 even? Nah. Let's do 2. Oh. So that would be 221 out of 1,250. We might be able to simplify that further, but that's your experimental probability that it's going to rain on Monday and Tuesday. So let's actually find that as a percentage. So I'm going to take 221 divided by 1,250. So this is my decimal form, 0.1768. Move my decimal 2 to the right. So I would have a percent of 17.68. Because remember, our probabilities we can write in percents, in fraction form, or in a whole value or a decimal form. So the likelihood that it's going to rain both Monday and Tuesday is then only 17.68%. So probably unlikely. Okay. Let's see what else we got in this lesson. 3. Okay. Let's take a look at this one. Each year there is a 50% chance the weather causes one or more school days and be canceled. Design and use a simulation involving 50 random number generators. Find this one actually, I mean, if there's a 50% chance, you could use a coin flip. So you could say like heads are we have school and tails we don't have school. And then doing it, 4 days. So like we did that flip, instead of doing 3 coins, do 4 coins. I'm actually going to leave it as this. If you want to do this simulation, you can, but this is just kind of an intro video on how to do those simulations. And this is an extension lesson, so we don't even have a worksheet, but I highly suggest you go and do some IXL or catch up on all the big ideas that you are missing. Remember, your IXL is just extra credit. Hey, code word. iPhone. See ya!